going to start with the division in algebra, which is exercise 6.7 in your work. And we need to remember, when simplifying algebraic expressions, we require the laws of exponents and distributive law, which we were using in multiplication of algebra. Again, we're just going to revisit laws of exponents. Okay, in the previous session, we had a to the m multiplied by a to the n. When I multiply powers with the same base, I write down my base and I add my exponents. Now we're going to look at division, right? And before, remember we said when I divide, I have to write down my base and I'm going to subtract exponents. Right, remember the first thing was circle terms. Then we had one term. This is one term. So the first law, our operation was multiply. And what do we do with the exponents? Well, we're going to add the exponents. Now we're looking at our operation is division. Okay, so if our operation is division, what do we do with the exponents? We subtract them. That you have to go and learn. Right, we are now going to apply the distributive law to division, because at this point in time, that is the only way you are able to do it. So for example, if I had 4a plus 6b, and that was over 2. There are no like terms here, so I cannot simplify that, but this can be simplified in the following way. So right, the first thing I'm going to do when I'm dividing, this tells me I'm dividing. So the first rule is I'm going to split my numerator. So I'm going to show you why it does work. So I'm going to take that. So 4a over 2 plus 6b over 2. And now I can simplify because 2 goes into 2 once, 2 goes into 4 twice. So on this side, I'm left with a 2a over 1, which is 2a. Now I look at the next term. I've got a plus, so I'm going to put a plus there. 2 goes into 2 once, 2 goes into 6 3 times, and I've got 3b over 1, which is equal to 3b. Now why can I do that? Well, let me show you using numbers. If I had 6 plus 10 over 2, that would be 16 over 2, which equals 8. Using the splitting method, we can do it like this. So I could have 6 over 2 plus 10 over 2. I could simplify this. 2 goes into 2 once, 2 goes into 6 3 times. So that is 3 plus 2 goes into 2 once, 2 into 10 goes 5. 3 plus 5 equals 8. You will see that my answers are the same. So we are using that in algebra to simplify. That's what we do when we do division. Right, so I've just written down the little method for you. You've got to remember that a denominator can never be 0. Remember, if I have 14 out of 0 for a test, your mother's going to say you're nuts. Okay, remember that is undefined because it is underneath. Right, so the first thing we're going to do, we're going to write the expression in fraction form, always. So what I'm saying here, if we had 4a divided by 2, we're going to write it as 4a over 2 in fraction form. Okay, use the 3-step approach that was used in multiplication. Signs, numbers, variables, or letters. And then you are going to collect the like terms. Okay, so let's do the worked examples. So remember, the first step is to write in fraction form. So I'm going to say that equals minus 24a squared divided by is this line here, 6a. Right, again we're going to do signs, numbers, letters. A negative divided by a positive is going to give me a negative. Done with the signs. Now I'm going to do the numbers. 6 goes into 6 once. 6 goes into 24 4 times. So now I've got 4 at the top. Letters, right. When I am dividing in algebra, I always look to see where the biggest number of A's are, and that is going to be at the top. So I'm going to say A. Over here, I've got an invisible 1, so I'm going to say 2 minus 1, which will give me 1, so that is A to the 1, and then that also cancels. So if I write that out nice and neatly, I've got a 4 and an A at the top over, and I've got a 1 times 1, which is 1, so that is negative 4A, and that is my answer to that simplification. Right, in your books you will find there is this little explanation to help you. Right, let's have a look at the second example. The first thing we're going to do is we are going to split the fraction. I just want to get a thinner. Okay, so that means I'm going to have that over that, and then I'm going to have that over that as well. Right, so now I'm just going to rewrite it. So that's going to be 15x to the 4 y cubed over 5x squared y squared. And then the other one, I'm going to write negative 5x squared y squared over 5x squared y squared. Do you see I've kept the negative with that term? So again, we are just separating our terms, and we're going to do each one separately. So again, we do signs, numbers, letters. A positive divided by a positive, so my result is positive. 5 goes into 5 once, 5 into 15 goes 3 times. You will see here I have more x's at the top because there's a 4. So I'm going to say 4 minus 2. The 2 comes from here. Okay, so 4 minus 2 is 2, so I will be left with x squared. Now I have a look at my y's. I've got y cubed and y squared. There are more y's at the top. So I'm going to take that 2 and I'm going to minus it there. So that cancels. Okay, I'm left with a y. When I divide powers with the same base, I write down my base and I minus exponents. 3 minus 2 is 1. Right, now I simplify. So at the top you will see I have got 3x squared y. So that is what I write down. So I'm going to sort out what looks like a bit of a mess. 3x squared y. At the bottom, I've got 1 times 1 times 1, which is 1. And that would be 3x squared y. So now I've done the first part. Now I'm going to look at this part. This is my second part. Okay, again, signs, numbers, letters. A negative divided by a positive will be a negative. The sign now goes in front of what I simplify. 5 goes into 5 once, 5 into 5 once. X squared into x once, x squared into x once. So you see, when my terms are identical, they just cancel with each other. And now I say 1 times 1 times 1 is 1 over 1 times 1 times 1, which is 1. And 1 over 1 is 1, so that is going to be 3x squared y minus 1. And that is your final answer. I have 2 terms. None of them are like terms. So that is the answer to that simplification. In your book, again, you will get the little explanation. Right, I want you to go and do your test, your understanding. I'm going to finish off here. When you've done it, please go and look at the video explaining the test, your understanding.